Okay, today we're going to take a look at comparing some information dealing with if 2 is to a certain power or if we're looking to the log base 2. And I want us to compare both what the tables look like and also what those graphs and properties look like. And so we're going to go ahead and fill in this table. Now these note sheets are in the module under this video, so make sure that you are filling this in. These tables are going to be really important. We'll come back and take a look at these throughout this unit. So we want to start by, let me get a writing tool here. 2 to the negative 2, remember that 2 squared is 4, right? And when it's to the negative, we switch the numerator and denominator. So this will be 1/4. And likewise, the next one will be 1/2. 2 to the first power is 2, but when it's negative, it becomes 1/2. 2 to the 0 power is 1. And then we continue on with those x values, right? 2 to the first power, 2 squared, 2 cubed, and 2 to the 4th. And so with this 2 to the x bar, we can start to take a look at what our graph is going to look like. So if x is a negative 2, we're going to have 1/4. We're going to have a point right here. And if 2 is negative 1, oh, that's not 1/4, is it? It's really only about 1/2. Let's clean that up here. Okay, so if x is negative 2, then y is 1/4, which is going to be right here. And if it's negative 2, it's going to be 1/2. As long as we have it close enough to those, we're okay. 0 and 1. Then we want to start paying attention to our x and y's. 1 and 2. X is 2. Y is 4. X is 3. And our y is 8. X is 4. And we're going to be probably about up here, right? And so we'll start to have this graph, and you'll see it has a curve to it. Try to attach those as close as possible, right? We can see that general shape of it. Okay, now let's go over and look at these logarithms, right? So if x was 1/4, our y is going to be a negative 2, right? 2 to the what power gives us 1/4. 2 to the what power gives us 1/2. 2 to the what power will give us 1. 2 to the what power will equal 2. And we continue on. And now we're looking at these with the logarithms of base 2. And so as we start to look at our graph, and we're going to plug those in, if x is 1/4, we'll have a spot about here. If x is 1, it will be on 0. If x is 2, it will be at 1. X is 4. Notice we jumped over some, right? X is 4, it'll be 2. If x is 8, it'll be 3. And if x is 16, so off the graph here, then we're going to have a 4. Now, as we connect these and kind of sketch out that graph, oh, let me get back on track here. There we go. As we sketch out this graph, what do you notice about these two graphs? Okay, you should notice that they're kind of like a reverse of the other one. They're not exactly a reflection across the x or across the y, but it is what is called as an inverse. And what that means is that we're actually switching those x and y values. They have a property where we've swapped our x and y. And it technically is a reflection right over this line here, which is y equals x. So if we look at these two graphs in relation to this line that I'm drawing here, that y equals x, which means y has an intercept at 0 and has a slope of 1. These two graphs have reflected over that and share a lot of similar but opposite features. And so, for example, if we're looking at our domain in this one here, what values are possible for x? Well, all of them, right? It'll continue on this way indefinitely. It will continue up and over indefinitely. But our range is y is greater than 0. Now let's take a look over here. Now here are our domain, right? What x's are possible? X is greater than 0. You see that this line will never cross that x equals 0 point. However, our range, what y values are possible, this graph will continue upward and downward indefinitely. Okay, so if we jump back over here, our intercepts, we have a y-intercept at y is equal to 1. That's the only intercept that we see here. And over here, we have an intercept of x is equal to 1. Right? So it's similar properties, but kind of the reverse of each other. We have an intercept of y equals 0. And over on this graph, we have an asymptote of x is equal to 0. It's never going to pass that y-axis. You'll notice as x goes to infinity, as x comes out in the positive numbers, y is also going to, as x goes to negative infinity, y is going to get closer and closer to 0. And as x is going in the positive direction, y is also going to go to infinity. If we look at this other graph here, we see as x goes to negative infinity, right, it really can only approach 0. But we're going to say that y goes towards negative infinity, right? What that means is as this x keeps going in this direction, our y is just going to get smaller and smaller and smaller and smaller in the negative direction. And as our x goes off in this direction, our y is going to get bigger and bigger right along with it. Okay, so this is a glimpse at this property that we talk about with exponents and logarithms and how they are what are called inverses of each other. They undo each other, but notice they also have some special properties when we look at the tables and when we look at the graphs of those two things.